right now, we'll take a look at the Meraki Developer Hub. This is where I was told to nerd out, and this is where all the nerdy stuff is.
Nerd out.
Always.
So the first page of this is always the how do I get started, and any good documentation will have that. How do I get started with these things? And you'll see if you kind of hover over the docs section, which for me, that's the place where I tend to get started. I look for the docs, and then I see that there's a number of different ways that I can interact with Meraki. The ones that we're interested with today are potentially the dashboard API, because we're dealing with SSIDs, or location services, which is the location scanning API for Meraki. Now, the location scanning API for Meraki is tied into the same kind of delivery as what I mentioned earlier around location services, mobility services engine, CMX. It's locating devices in that Wi-Fi space, but this is Meraki's version of it. And similar to Meraki having their own wireless service, they also have their own way of providing location services. And the documentation will walk you through, hey, this is what the architecture looks like. We have our devices interacting with the APs. The APs report a location guess to the Meraki Cloud Service, and then the Meraki Cloud Service will push that data out to a receiving service. And so there are elements within the dashboard that allow us to configure those receiving services, and I'll just do a quick rundown of that. Now, all of these things that I'm showing are provided through DevNet as far as tutorials on how to complete these things. This particular network has, I got lost, a location scanning enabled. And if I wanted to add one of those services URLs, this is where the developer piece comes into play. So I have Meraki working in the cloud. It's like I said, it's a fully managed cloud service. If I wanted to talk to another service that I can control, I'll put in the web location of that particular service. And so a lot of times for the tutorials, you'll see a tool called ngrok being used to expose your laptop as a web server. Or you could deploy your applications to something like AWS or Heroku or Azure. As we start to work in these web application spaces where a lot of applications tend to live, those cloud-hosted services tend to be the easiest place to put things and not have to deploy your own web server, which I've tried and failed to do in the past with Apache and Tomcat, and I still don't know the difference between the two. It is nice that someone else is doing it for you and just charge.
Someone else's computer in the cloud. That's the answer.
Yes, exactly. Did you guys see that meme with Morpheus and it says, the cloud is just someone else's computer? Have you seen that one?
Yeah, no, I saw it. In fact, I think I might have it saved some.
In fact, no, let's not go down that road.
Yeah.
As we move forward with this, for developers, things can get a little dicey, especially in the wireless space, because to virtualize wireless interaction is almost impossible, right? And so, to be able to generate a situation where you have an access point that someone has to interact with to cause something to happen, whether that be a location update or those captive portals I was talking about before, you have to have those access points in your sphere of access, right? So unfortunately, we can't provide that for everyone. And so what we did at DevNet was we built out some simulators to help with that. Now, I will give credit to the idea for the simulators coming from the classic wireless networking group. They built out a wireless LAN controller image that created fake access points, fake clients, and it associated and deassociated those clients with the fake access points. So we were able to, and move them around a space. So we were able to use that for the classic Cisco infrastructure. But because Meraki is different, we kind of had to build our own. And so I have a little demo of that running. And for those nerds out there, this is the I'll bring up the code for it just real quickly.
Nice.
Let's see here. location scanning Python. This is the location scanning simulator. And it is all Dockerized, so we can run them in Docker containers, and then I actually have it all being managed by Docker Compose. So Docker Compose is a way of managing multiple Docker containers at the same time. And so within this file, you'll see things like generate client MACs, and it's using random choice. So it's generating fake MAC addresses. There's two different kinds of connections for devices. They can be seen where they're not actually connected to the Wi-Fi, they're just probing, or associated to it where they're actually collecting data from that Wi-Fi. So we have a little algorithm in here that figures out if it's seen or associated and to which access point. The MACs themselves for the access point are fake, so we generate AP MACs. We have something to actually kick off the simulator, and we have built in a bunch of different operating systems that could be tied to specific manufacturers. And so what this does is it generates GPS location for fake data. And the cool part about this, in my opinion, is that you can, when you launch this simulator, it's a locally run web application. You can pick the number of access points that you want to deploy. Let's just say there's 4. And for some reason, I always pick these two numbers, 4 and 16. And we can configure those to generate the number of clients that are being generated each time the data stream is created. And then what we can also do is hone in on a particular address. And I will, maybe it's not good to put my home address on here. The West Tasman.
You might hear Rick knocking on your door in a couple hours.
And using the Google Maps API, I'm able to navigate to the space and set up I can't actually place the APs. That was going to be a lot more work than was necessary to generate it. But it will kind of center on your address. And then when what you want to do is simulate the experience of here, right? So simulate the experience of the post URL receiving data. So we still need to run that location scanning receiver, that application that's actually taking in the data. And that's what we're looking at in this particular portion. So we have to configure that on this side. So it's very similar to what the experience would be through the Meraki dashboard. It's not exact for various reasons, but it is close. And the main part is this scanning receiver. And you can see it's got a preset location that it's at, and it should adjust as things are being found. But the idea is that we then develop applications against our simulators, and then they should port right into our production service. So I'm going to launch this and keep my fingers crossed that everything works out. What I should see then in my all right, so we are getting data generated. That's good. I'm going to go to running to make sure that we are looking good there. So we have data being generated. Now what should happen is this should update to the space that we were looking at, and it'll move clients around this area. Now, there is a limitation to this particular simulator in that it only provides GPS coordinates versus XY coordinates. That's another differentiation between classic Cisco infrastructure and Meraki, in that and you'll see all these move at the same time. But it found 16 clients, so we're excited about that. If we wanted to follow a specific client, we can clue in on that one. But the difference is that Meraki starts at the GPS coordinate level, because when you set up these, let me go back to that first one that I looked at 1 second here. When you set up these maps and actually place these devices, they use Google Maps as their baseline. Right. And so it's all configuration based. There's no fancy magic going to it. They put this access point here. And so if there's a client here, it's going to have GPS coordinates very close to where that access point is. So the XY coordinates come in when you actually create a floor map and then tie that to the actual map image that is sitting here. Now on the flip side, Cisco CMX and then now into DNA Spaces set up the floor maps first, and then you put in GPS markers onto the floor map. So it is very configuration heavy. But once that configuration is in place, ideally it won't change for a long time, and you can generate location reports for both Meraki networks and classic Cisco networks. Now, any questions or comments on that particular demo? I can leave it open to the floor, and then I have one more thing I want to chat about before we call it.
Well, before we get there, can you go back to the script?
Yeah.
So actually, this is, even though these are DevNet sessions, right? This is the first time that people have seen actual code, right? So, and correct me if I'm wrong. In fact, I think all these scripts, right? They're actually published in a SDK, right? Which SDK are these scripts? And just so if someone wants to go in and look at the scripts and get familiar with the scripts, where would they go?
So actually, these are not published in an SDK. They are published as part of our sample code that comes with our learning labs.
Okay.
And the ones that we're looking at today, the ones that are this location scanning one that we just took a look at, was under learning labs, developer.cisco.com/learning. And then this is in the modules section and getting started with Meraki. Or you can just go right to modules, getting started with Meraki. And that'll be under the location scanning API. It'll walk through everything that we just kind of did and allow you to either configure, if you have access to a Meraki organization, configure that in the dashboard, like we saw in this general area, or use the simulator to build out a sample app before we go through the process of interacting with Meraki. So those are our two options there. Whoops. And so that's where that lab is. All of the code for that then, the way to get all of that code is kind of outlined in the lab itself. And I find that to be the easiest way to get that information. If it matters, you can also go to github.com/Cisco DevNet. And in there, we will have Meraki. If you just search for Meraki within there, we'll have a bunch of different Meraki repos, but we have the Meraki location scanning application, which is the listening service that's sitting here, or the simulator, which is in a separate repository. Where did I go? GitHub. The simulator is. They should do these in alphabetical order. Yeah.
There it is. Yeah.
Too easy. Too easy.
Simulator. So the nice thing is we do a lot of teaching, and this is a necessity for us, right, to be able to scale these engagements for developers to be able to write scripts that do this stuff. Now, we just provide a very simple location scanning receiver that collects that post information, and this is what's called a Python Flask Web App. Flask is just for those not indoctrinated, it's a web framework. It's usually used for putting together proof of concept applications or sample applications. It's not usually supported in production environments. For that, you would want to move to something like Django. So I would Google those, and if you're interested in what web frameworks for Python exist.
Right. Just for people listening, Django is not the movie, right? So it's something different.
It's spelled the same way.
I was just going to say the same way, though.
Yeah, DJANGO. But this is good.
But just to add on, right, what he's using right here, I mean, I can tell that, or I hope anybody's not getting intimidated, right? So he's working on Visual Studio. Oh, no, this is Xcode. It looks like Xcode.
No, this is Visual Studio Code.
Okay. So he's working on Visual Studio. We'll talk about that in later sessions.
Yes. The thing that I wanted to point out is you can see not a lot of lines of code here, 154. But the main meat and potatoes is this is a web app that's sitting there waiting for post data to come from somewhere, whether it be our simulator or our Meraki service. And when it receives that post data, then it does something with it. It grabs that location data, and for us, it just sends it into a variable called location data. So that's all that's going on here is it's parsing out that location data. And then there is a JavaScript service on the front end of this application that's pulling the location data from this backend service. So it is there are multiple pieces to it, but this is actually as simple as we can get from a receiving service to then post to a web application that we can navigate to. So this is running locally on my laptop. And so that's why you'll see the local host port 5001. And that's why we see this going on here. I could take this application, package it up, and ship it to a public service that is accessible, but I'm not going to do that today. But this example, I personally think is a really good baseline for understanding how, one, how location data is collected, and then two, really how to use that data to create mapping applications. Now, if that's not something you're interested in, I wouldn't super worry about it, but this is still collecting that location data. We can see it showing up in the console here every time. Down here, we have the terminal collecting that location data and printing it out in a nice fashion. So we have our latitude and longitude for where we placed our access points and the clients that are being found there. This is, I think, a great starting point for kind of wrapping your head around how to collect that data and use this as a jumping off point for building potentially your own applications or just understanding how it works in a lot of instances.